Alright, so in this video I'm going to take a look at the DC circuitry end of unit test and look at how you can go about getting the correct answers to these questions so that you can understand what processes you need to be going through to get the answers to these questions. So first off, in this question here, it tells you the reading of the voltmeter is 8 volts. So that means going across this section of your series circuit here, you have 8 volts. And it asks you to calculate the current in the circuit. So when I'm seeing this, I'm immediately thinking of Kirchhoff's series voltage law, because some of the potential differences in a series circuit must be equal to some of the EMFs. So the sum of the EMFs is just this one, because there's one EMF source and it's 12 volts. So that means across R2, you must have 4 volts. So 4 volts plus 8 volts equals 12 volts. Now, it tells you in the question here, R2 is 60 ohms. So if we want to calculate the current in the circuit, so we can calculate the current in the circuit by calculating the current going through R2, since the current has to be the same everywhere in this series circuit. So, first of all, let's get Ohm's law into a useful form. So we want to calculate the current, V over R. So we've got the potential difference across it is 4, the resistance of it is 60, and if we put that into your calculator, you will get a value of 0.067, and that's giving it two significant figures because the value you're using in your equation, we've got this is one significant figure, this is two significant figures, so it's determined by the fewest number of significant figures, which would be 1, but remember we never give one significant figure answers, we always give two significant figures if we find a moment that 1 would be appropriate. So we move on to the next question. So we want to calculate the resistance of R1. Again, we look at applying Ohm's law. So we want to calculate R, so it's going to be V over I. So the potential difference in this case was 8 volts, and the current was 0.066. Remembering we use unrounded versions in the calculations, and this comes out giving it two significant figures at 1.2 times 10 to the 2 ohms. So that's how you give 120 as two significant figures, which would be appropriate here. Now, next question. Calculate the charge passing through the battery in 2 minutes, giving an appropriate unit. So, calculate the number of charge. So we're going to be using this equation here. So we already have current and we have time. So this is going to be your 0.066. Remember we need time in seconds, which is why we'll multiply it by 60 in this case. And once you do that, you'll end up with giving to the right number of significant figures 8.0, and the unit of charge is coulombs, which has the symbol C. Okay, so that's that part. So moving on to the next. So in the circuit, you're replacing R2 with a thermistor. So if we can see R2 replaced with a thermistor, state and explain what will happen to a reading on the voltmeter as the temperature of the thermistor increases. So a couple of key things to remember in this one. Your voltmeter is connected across R1. Your thermistor is replacing R2. So you're interested in this potential difference across this one, essentially. So let's put some of the key things. First, for a thermistor is an NTC component, which means that as temperature increases, the resistance will decrease. That's just a fact that you have to know. Next thing, we want to be using our potential divider equations to calculate across the potential difference across R1 Okay, so what we need to identify first is what's going to be constant. So the EMF source is constant, R1 hasn't changed, so R1 is constant. So all of these terms are exactly the same. So if R2 decreases, this whole bottom line has got smaller, which means this fraction overall has actually got bigger. So if the bottom line gets smaller, the value gets bigger, which means that the potential difference across V1 is going to get bigger, and it's because of these two steps. First, identifying what happens to the resistance, and then explaining how the resistance links to the potential difference reading on the voltmeter, and you need to go through those stages to explain it. If you just say something random without justifying it, that's not going to get you these 3 marks which are available here. Okay, so that's question 1, and I will go on to question 2 in a subsequent video.